y squared minus 4y must equal 2y minus y squared. And then, so setting everything to one side, so adding y squared and subtracting 2y gives you 2y squared minus 6y equals 0, and just solve. So factor out a 2y, so we know y equals 0 and y equals 3. And there's your bounds of integration. Now again, notice you can actually do this with respect to x, but it's going to be really horrible when it comes to it. So that's right, because you have to solve for y. I'm pretty sure you don't want to solve for y. And that's why we do this kind of integration here. So now it's going to be from this value to this value, bounded by those two curves. So the area is going to equal to integral from 0 to 3 on the y-axis, right, of the function itself. So remember, is right minus left. So the rightmost one is going to be this one, which is this one here. Minus the leftmost one, which is this one, and that's that. dy. Yep. And then we just put it together, make it easier for ourselves. This is integral from 0 to 3. Let's see, so 2y, this ends up being positive, right? Plus makes this plus, so this can be 6y. And then here it gives you negative 2y squared dy. And again, notice just a simple power rule, right? So this is going to be that. Evaluate 0 to 3. Right, and then we just plug it in. Right, so plug in 3. This is going to be 9. 9 times 6, or actually I can simplify this a little bit, so let's just do that real quick. This is 3y squared minus 2y to the third over 3. So if I plug in 3 now, that's 3 squared is 9. 9 times 3 is 27. Minus 3 to the third power is 27. If you divide by 3, that's 9. So that's going to be 18. That's the first part. And notice subtract 0. Right, because you plug in 0 and just gone. So 27 minus 18 is our area, which is a nice 9. Look at that. So area is 9. Couple more. Find the area of the region bounded by the curves y equals x e to the x and x equals 0 and x equals e itself. Ooh, okay, let's see what's going on here. All right, let's graph the curve. Y equals e to the x, so if x equals 0, we get 0. If x equals 1, we get e. So up there. X equals 2, we get 2e squared, which is shooting up really high, right? So it's like way up here. But the good news is we bounded from from 0 to e. So let's say e is roughly 2.7. So this is e. So kind of bounded by that huge little arc there. So it's pretty high you could go up. So roughly estimate how high you go up. Okay. Now this one, you could just do straight integration, right? So this one is not like the example before, because there's no left minus right in this case, because you could technically find it, when are these two curves actually bound, but I'm not sure where exactly it is. So if it's easier, you would just do a straight integration. Integral from 0 to e of e to the x, of x e to the x. Actually, we want this, right? Yeah. E to the x. I don't think you guys have that in your book. So straight out e. So it's a little easier to deal with. Yeah, that's what I want. So that just e to the x, 0e, and plug it in. So this is e to the e minus 1. And there you go. All right, last question. Find the area of the region bounded by curves x equals y squared minus 2. So you already got the hint. It's going to be like this. And x equals e to the y within y equals 1 and y equals negative 1. So again, let's see what's going on. All right, so just starting here. So if y equals 0, x is going to be negative 2. So we're over here. When y equals 1, x is going to be negative 1. When y equals 2, y equals 2, this is going to be 4 minus 2 is 2. So when y equals 2, we get positive 2. If x equals if y equals negative 1, that still be 1 minus 1 is negative 1. So when y equals 1, we get negative 1. So notice this curve is going to go like this. So it's symmetric, right? It's a parabola. So this is negative 2, so it's going to be negative 2 down here. So like that in the direction. And x equals e to the y. So when y equals 0, we get x equals 1, which is right here. When y equals 1, we just get e. So roughly a little higher than 2. Okay. And if you guys don't remember, e to the x kind of looks like this. So it's going to cut it like that, in this direction. So the area we care about is this chunk right here. And good thing is we're bounded, right, between 1 and negative 1. So basically right there. That's the little region we care about. So it's going to be integral from negative 1 to 1 of right minus left. So the right one is e to the y minus the left one. dy. All right, and just integrate as normal. Plus. Okay. Plug in 1. This is just going to be e minus 1/3 plus 2 minus. Plug in negative 1. That's just e to the negative 1 power plus 1/3 minus 2. Okay, so breaking this down, this is going to be e minus e to the negative 1 power, and these being 4, right, because addition becomes 4, and this is a negative negative, so this is going to be plus 4 minus 2/3. So e minus e to the negative 1 power plus, what's this going to be? 3 1/2, 3 1/3. And there we go. So if you want the exact answer, I can give it to you. So it's approximately that. And there we go. So that is area between two curves.